Hi guys. So today we're going to look at something called piecewise functions. What piecewise functions are is they are a certain function in part of the domain and a different function in another part of the domain. Remember, domain is your x's, so side to side. Now you can have a bunch of different little pieces. You can just have maybe two different ones, but the point is that it's different functions for different x values. Okay, so we're going to start off by graphing one of these. Now it is really important that you guys remember what your parent functions look like. That's going to make this a lot easier, especially with your transformations that you did in Algebra 2. So let's look at the first one. So the way your piecewise functions is going to be listed is you'll have a function, and then you'll have the domain where that function is going to be drawn. Okay, so you have a function, and then you have the domain, you have a function, and then you have the domain. Okay, so the way this is going to work, we'll start with the first one on here. I'm going to graph the line y equals 2x plus 2, but I'm only going to graph that line where x is less than -1. So the first thing I like to do is I like to plot that border point, okay, the furthest, in this case, to the right that this graph is going to go. Now, if you don't remember what the line 2x plus 2 looks like, you can always plug in points. So I can take -1 and plug that in for x. Well, if I do that, I'm going to get 0. So I know -1, 0 is a point for that graph. Now, what I need to be careful of, though, is that it says where x is less than 1. It does not say less than or equal to, which means this is actually going to have an open circle at that point. Okay? Then, every x value less than -1, so every x value anywhere over here on the left is going to be plotted on the line 2x plus 2. So remember, that line would have a slope of 2, so I could just follow that slope to find the rest of my points. Or if I don't remember that, or if I'm not sure what it's going to look like, I can plug in some more points. I could plug in, for example, -2. Well, if I plug in -2, I get -2. If I plug in -3, okay, if I plug in -3, I would get -4. So I can plug in any x value as long as that x value is less than -1. And that's what my graph is going to look like for everything to the left of -1. Now I have to graph this middle section. Okay, now I look at the domain that's listed. That's telling me that x is in between -1 and 2. So all of the x's in between -1 and 2, I'm going to graph the function x squared minus 1. Okay, so in between those numbers, let's pay attention to our less than and equal to's. Okay, so it is equal to -1. So the first value I'm going to plug in is I'm going to plug in -1. Okay, so if I plug in -1, -1 squared minus 1 gives me 0. So at -1, this graph is going to be at 0. Now, I already had an open circle there. That's okay. If there's a closed circle and an open circle in the same place, the closed circle is more important. That basically fills in your open circle. So you don't even have to worry about it anymore. There's just going to be a closed circle there. And I'm using different colors to help you kind of see which part is which part, but you'll usually see these as just one color. Okay? Now, to remember what this graph looks like, x squared minus 1 is a parabola that's been shifted down 1. But again, if you don't remember exactly those points, you can plug in some points to find out. If I plug in 0, because 0 falls in between -1 and 2. If I plug in 0, I get -1, so 0, -1 is a point. If I plug in 1, I get 0. And if I plug in 2, I would get 1. If I plug in 2, I would get 3. But pay attention here, because again, it's when x is less than 2, not when it's less than or equal to it. So I need an open circle when I plug in 2. So I plug in 2 and I get 3. I'm going to plot an open circle there, and I'm going to connect my dots, and that's the middle part of my graph. Alright, now I'm going to look at the last part. This is a square root function. Okay, so remember your square root parent function looks something like this. Okay, but this has been shifted to the left too. So again, to find the exact points, I can plug in any x value that is greater than or equal to 2. So let's start with 2. Okay, I plug in 2, the square root of 4 is equal to 2. So 2, 2 is a point on my graph, and it is going to be a filled-in circle. So those points don't meet, and that's okay. It does not have to touch. Okay, if it does touch, you go ahead and fill in the open circle. In this case, it doesn't. Okay, then I can fill in some other points. If I pick 3, it's not going to be a very pretty point. So let's pick an easier x value, maybe something like 7, because 7 plus 2 is 9, and the square root of 9 is 3. So if I plug in 7, I have a little bit more space. Let's see. Here's 7. 7, 3 would be a point on my graph. Okay, so that's what piecewise functions are. It's different pieces of different graphs for different domains. So it's just important to pay attention to where you're graphing each part. Okay, and again, pay attention to your less than or equal to's, or if they're not equal to. That's the difference between your open circle and your closed circle. Now let's look at a piecewise function that's actually drawn, and let's try and write the equation for it. Okay, so let's start with this first piece over here on the left. Okay, this is just a straight line with an open circle. Well, we know a straight line has the equation. Let's go ahead and write it. That's my bracket, sorry. That would be just the equation 3, y equals 3. Now I need to find the domain where that happens. Okay, so that's all of the x values. The biggest x value is -1. It is not included because it's an open circle. So this is going to be everywhere that x is less than -1. And that's how I'm going to list it. Okay, everywhere that x is less than -1. So it's the function y equals 3 everywhere that x is less than -1. Now let's look at our middle graph. Okay, this is a parabola. It looks like y equals x squared, but it's been shifted up 1. So that graph would be x squared plus 1. And then the domain here, it's in between -1 and 2. So x is in between -1 and 2. It does touch -1 with a filled-in circle, so that's going to be less than or equal to. It does not touch 2, so I'm going to leave that without the, as just less than, not less than or equal to. Now the last part on here is a line. Okay, so I need to find the slope and the intercept for that line. Okay, so this line has a slope of 1. And if I were to keep counting up, or keep following this line up, it would have a y-intercept of 4. So this would be y equals -x plus 4. And this is all of the values where x is greater than 2, but it also could equal to, so this is x is greater than or equal to 2. And that's your piecewise function. All right, the last thing we're going to do with piecewise is actually trying to evaluate them without looking at a graph, just by looking at the equation. And what's really important here, again, is your less thans or less compared to the less thans or equal to. So from looking at this piecewise function, I'm going to evaluate these different things. So the first one on there is f of -4. Okay, f of -4 means when x equals -4, what does y equal? Well, I need to figure out which of these 3 functions makes sense to plug -4 into. Well, -4 only really works when x is less than -2. So I'm just going to use this function. I'm going to plug in -4, and I get -12. All right, the next one, f of -2. The one that actually touches -2, okay, is the x cubed function, because it's when x is less than or equal to. Okay, so since it's the or equal to, I'm going to take -2, plug it into the middle one. -2 cubed is -8. 0. 0 falls between -2 and 3. So 0 would get plugged into the middle function as well. 0 cubed is 0. 3 is going to fall on the last function because, again, it's greater than or equal to. So it's or equal to there. And then this is just the line y equals -3. So it's just -3. 7 also falls greater than 3. When x is greater than 3, that also is the last function, and that is just -3. All right, so that's how we can use piecewise functions to evaluate these different points, but we're probably going to do more graphing than anything else. So it's really important, if you're not familiar with your parent functions and your transformations, you may want to look those over because it'll make this graphing process a lot easier.